Okay, so the last unit that we did was measurement problems, or measurements, and converting. So now what we're going to do is we're going to combine some of the unit changes that we did in the last one and apply it to actual problem solving when we're measuring different objects, okay, or symbols. So a variable is a letter or symbol such as an X, a T, or a Z that represents a number. To figure out the value of a variable, perform the same operation to both sides of the equation until the variable is alone on one side. Simplify the other. What are you doing? All right. Solve D in the equation. D equals 2R when R is 3.5. Okay, so there's two ways in which we can do these questions. The first way, probably the easiest way for most, is to actually go ahead and put your values in and then solve it while the values are in there. Now, if I were to ask you, let's say, it's completely different than the question asked, and I'll explain that in a second, but if I asked you to solve for R, and you knew what D was, most of you would put a number in for D, you would divide by 2, and that would be fine. Now, what I like to do is I like to get the R by itself, so I would automatically divide by 2, and then I could put whatever in a D and divide by 2 at that point. Okay? But here's the question. D equals 2R. What do the symbols represent in this equation?
Diameter and then maybe your radius.
Diameter and then maybe your radius? So is the diameter twice the amount of the radius?
Yeah. Yes.
Yeah, it is. Right? So what we know from a circle is all the way across the circle is the diameter, agreed? And then half of that distance is your radius. So that's exactly what this question states. If the diameter, if I want to find out what the diameter is, I take the radius. In this case, they gave you a value of 3.5. And I substitute it in and I multiply it by 2. So my solution then is 7. Correct?
Yeah.
All right. Solve for R now. So this is what I was just talking about. If I ask you to solve for R right now, how do you get R by itself in this equation? I'm going to divide both sides by 2. That cancels those. And that would leave me with R equals D over 2. And they gave us D as a value of 17. And 17 divided by 2 is 8.5. Good math. Perfect. Okay? So far, so good? Yeah. All right. Now, take that equation sheet that I gave you. Do you have the equation sheet from the test? You have the equation sheet from the test? I want you to pull it up, please. Everybody have that equation sheet out? Yeah? I want you to flip it over to the back side. This is what we want to work with today. Okay? So on the back side of that sheet, it gives you areas and volumes of a variety of different shapes. So to begin with, let's talk about the shape that I have right here. You know what the letter P stands for?
Perimeter.
Perimeter. So perimeter is found how?
On the length around the, the lengths, let's say for square, lengths around, lengths of all the sides added up.
Okay, great. So if my side lengths were L and W, all right, how would I find the perimeter of that object? Put your hand up. The perimeter?
Oh. So if you knew what,
I know what it is. I know it's L and I know it's W.
So what do you mean? If
I
you
wanna know
have
how
to know one of the...
Yeah, you're right, but if I just have L and W as my side lengths, what does the perimeter equal? Is that it?
L times 2 plus W times 2.
Yeah. Okay, so I would have twice the length, because L plus L, add
2W.
2W, because I have two widths. That would be the perimeter of that guy, right? Good, Kaylin? Who can tell me what the perimeter of that guy is?
Isn't it the area around 3 times?
3.14.
Pi times radius squared, isn't it?
Okay, you're getting closer. You gave me the area of the circle. So you're close.
Is it pi times diameter?
Pi times diameter. Yeah, I don't like using that one, but I'm going to put it down because you are absolutely correct. But I use this one, pi r. So 2 times pi, which is a button on your calculator, right? We won't use 3.14, we're going to use our calculator button that gives you all the decimal places to be more accurate. And I multiply by the radius. Now, the reason I do this is when we get into, when I get into grade 11 and 12 pre-calculus, okay, alright, anyways, just leave it, I don't mind. When we get into pre-calculus, we deal with what's called radian measure. So you guys are used to measuring angles in degrees. There is another way in which we can measure an angle. We refer to it as the arc length instead of the angle, and we use 2 pi times r to get that value. All right, and it's all a portion of the circle. So we're going to use 2 pi r as our perimeter of a circle. Okay, now let's talk areas now. The area of that guy, somebody gave it to me already. It was you. What is the area of that rectangle? Length times width. Perfect. And Charlie, area of the circle?
Nope. Pi times radius squared.
You gave it to me already. Right? Okay, so we got pi r squared, we've got length times width. So far, so good. So on the back side of that sheet, it gives you a number of different objects in which we could do it. Now, in grade 10 and 11, again, we use all of these shapes. We use all of these shapes, and we measure all of these shapes, and we find missing side lengths, missing radius, missing diameters, whatever they are, from all of those shapes. Okay? So now, I'm going to put this to this and go like that, and calculate the perimeter, area, or circumference. So if L is 5 and W is 2, what is the perimeter of a rectangle? So 2 times L, which in this case was 5, plus 2 times the width, which is 2, which gives us how much? 14 centimeters. Okay. What about the area now? Area is length times width. What was the measure of the length given to us?
7.
7?
Yeah.
And the width was?
4.
4. Therefore it is
20.
28 centimeters squared. Okay, so we have to keep practicing our units as well. We need to have the right units in there. See? The area is given, the length is given. We are asked to find W. Okay? Before I put any numbers in, can somebody tell me what W would be equal to?
5.
Before I put numbers in,
6.
before I put numbers in, how do I get W by itself here? What do I do?
Divide.
Divide the area by the length.
All right, so I would have this here, which is area divided by L. We agree?
Yes.
Okay, now I don't have a problem if you put numbers in first. 54, maybe I'll put the units in and get practiced at that. So that's centimeters squared is equal to L, which is 9 centimeters times my W. So I have to divide.
They're both meters.
Are they both meters?
Yeah.
Yep, you're right. So much for getting that right. Okay. All right, so W is 54 divided by 9, which is 6 meters. So far, so good?
Good.
C. Circumference is equal to pi times d. Since they gave us, I don't like it again, I like using 2 pi r, but because they gave us the diameter, we'll use it. So I have pi times 5 millimeters equals. Okay, so using your button on your calculator, 3 decimal places now. Use the pi button, not 3.14. I know it says to use it here, I don't like it.
Where's I can't find it on my calculator.
Can't find
I
the
don't know if
pi
there's like
button.
a second function. It doesn't, like it shows pi, but I don't know how to.
Yeah, me
Shift pi.
Where is this?
to 3
Shift
decimal places.
That
or-
button.
Oh shit.
15.707.
Is that rounded correctly?
Or 708.
All right, don't forget to round properly. Okay. Right there, shift pi.
You didn't hit pi, Michael. You hit that
Okay.
X2 button.
Got it?
Anybody not get it? Yep. Ben, you have it?
Yep.
So you times that pi by 5, right?
Yes. Yep.
Times 5. And then
You get it? Okay. Yeah, so yours.
Michael's hitting this, Haley. He's hitting that.
no, I'm not.
I watched you.
Look at that. I got it. I press shift and then that.
Hit that SD
Okay,
button.
hit times
I got that.
5.
Is that it?
Okay, now hit the SD button and I'll do it to you as a decimal. Okay, so now they give us the circumference and we gotta find the diameter. So how do I get diameter by itself? Divide by
2.
d, right?
Yeah.
No, divide by pi. So 31.4 divided by pi.
Do we do the number or pi?
No, I want, which do you do first?
Yeah.
You're gonna put 31.4 and then divide by the pi button.
9.995.
What is it?
9.995.
Counted correctly?
Yeah.
Okay. And units?
Oh, this is centimeters.
So far, so good.
What is that doing?
Look at the sky.
It's a monkey.
Okay,
I just
converting. So look at the next page, 6. Actually, we're just gonna skip that. No, we better not. We haven't talked much about adding and subtracting fractions. So let's look at the first. I'm gonna skip the top part, you can fill that in after. But I wanna know how to add this. 3/4 plus 3 5/8. How would you do that, Galen?
We'll all make them the same units, like
Equivalent.
equivalent. Not equivalent, but like make them like so.
Same denominator.
Like same
Same
denominator.
denominator.
So like if it's 8, so 4 can go into 8, so just times
Okay.
4 by 2.
But is that the first thing that I'm going to do?
Oh no, make no what an improper fraction.
Okay, so let's start with that. So
So
I've got 3/4 plus,
3.58. So we times 8 by 3.
29. 29 over 8.
Charlie? You're right.
29 over 8.
29 over 8. 8 times 3 is 24. 24 plus 5 is
29.
29, right? Okay, so now what's the next step in this?
Make them equivalent.
Same
So-
value.
Like
Same denominator, common denominator. What's common between 4 and 8? What do they both go into?
8.
8.
So what do I multiply 4 by to get 8?
2.
2. So whatever I do to the bottom, I do to the top.
So
We agree?
35 eighths.
6 over 8.
Oh, wait.
6 over 8.
Wait.
6 over 8.
Yeah,
I mean, 35 eighths is the
I was
answer.
talking about the end.
Yeah, you're good. You're good, Michael. Just pace yourself.
35.
So 6 and 29, we add those together, we get 35 over 8, right?
Or 4 and 3/8 if you want to do it.
Or 4 and 3/8, Ben. That's right too. You're right. Okay, so anytime you're working with fractions, when you're asked to add, subtract, multiply, or divide, I would make them all improper fractions. Okay, if that's necessary. If you've got if you've got a mixed fraction, change to an improper and add them together. Fair enough?
Yep.
Yeah. You might not remember that. Okay, so far you guys are all right? All right, we'll leave that page now. Let's flip over to, you know what, I don't think I need to go through any of that or that. Let's look at page 69. I'm gonna skip ahead. You guys are gonna be able to fill in all the other stuff after. I wanna go through example 1 with you. Caden is a baker. He cuts 14.5-inch roll of dough into 1 1/4 inch slices for cinnamon buns. How many buns can he make from one roll? All right, so he has a roll of dough, which is 14.5 inches. Okay. One bun, or no, he cuts it into 1 1/4 inch slices, right? 1 1/4 inches. And it says, how many buns can you make from one roll? All right. So what do I, just in words, explain to me what the question's asking.
Like how many buns can you make out of one roll?
All right. And how would you go about solving this?
Divide.
Arlie?
Would it be 14 and a half divided by 1 1/4?
All right. So 14.5 divided by 1 1/4. Will we all agree with that?
Yeah.
Okay, so I need to divide these two, so I have 14 1/2 divided by 1 1/4. So where do we go from here?
I guess the reciprocal.
Make them improper fractions.
Yeah.
Make them improper
Oh, yeah.
fractions first. So that leaves me at 29 over 2 divided by 5 over 4. Do we agree with that math?
Yeah.
Yeah?
Wait.
2 times 14, add 1. And 1 times 4, add 1. Follow? Okay?
Sounds like
All right. When it comes to dividing fractions now, how do I do it?
Yeah. The trick is like you make it multiplying, then you switch the one on the right to 4 gets.
Yeah, very well said. Very well said. 29 over 2, and I multiply by the reciprocal. Multiply by the reciprocal. So the reciprocal means I flip the numerator with the denominator. Basically speaking, change your fraction, make it upside down. 4 over 5. Agreed?
Yeah.
Okay? Now we gotta do the math. Without the calculator.
116 tenths.
116 tenths.
Yes.
Okay.
make it easier and reduce 4 and 2.
I like that too. Change that to a 2 there, right? 4 divided by 2. So now I have a very similar problem. So instead of 116 tenths, I have 58 over 5. Correct?
Yes.
How many times does 5 go into 58? 11 times.
55.
And how much is left over?
3/5.
3/5. So how many buns How many total buns can you make here?
11 buns and 3/5 of a bun.
And 3/5 of a bun. Does that make sense to everybody?
Yeah.
Yeah, Becky.
I just use decimals instead.
Good. I like you to continue with fractions. If they give you fractions at the start, then I'd like to see you stay with fractions all the way through.
Yeah, that's what I thought.
Okay? This is good. I like using fractions because it works on your mental math skills without actually working on your mental math skills.
Yeah.
You know, Charlie, good point. Reduce the fraction if you can to make it easier to do the mental math. All right? Okay? So we did all that. Jack raises a car 3/16 of an inch for each stroke of the lever. How many strokes are needed to raise a car 1.5 inches? Okay, so I want to raise the car at 1.5 inches, and each time I pump on it, it goes 3/16 of an inch. So how do I determine, Kayla?
Well, I was gonna say, well, first you divide 1.5 by 3/16.
Okay, so let's start with that. 1.5 divided by 3/16 of an inch. Do we all agree with that?
Yes.
Yeah? Okay, what's the first step?
Well, first making an improper fraction, which would be 3/2. But then I was gonna say, oh yeah, I guess you have to do that.
Times by
16/3.
16/3. What is the answer to the question?
Well, first I'd make it improper, so it'd be like 1, and then 8. So 3 times 8 would be 36.
Actually,
Charlie, help me here.
you can practically reduce the entire equation, 3 and 3 and 16 in half. What did I got?
I'm confused.
And then I changed over 1.
So if there's a value on top and a value on the bottom, that a number can go into both of them, we reduce it right away. So this 3 was on top here, right?
Yeah.
And there's a 3 on the bottom, so when I go 3 divided by 3, what am I left with?
1.
Just 1. And if I have 16 and I divide it by 2, what am I left with?
8.
8, so I've got 1 times 8 then.
I didn't get caught on last year.
Math made easy, right? Make it simpler for yourself, and it's an easy thing to do. Okay? What do you guys think? Are we all right?
Yeah.
They did theirs a little different, but I'm okay. I think this is the easier math right here to do. They changed theirs to 16ths. So they changed 1.5 to 16ths and then multiplied it, so you can't, but I think this is simple enough. What do you think?
Yeah.
We're okay? All right, so what we have left to do then today is that kind of page 6, I think it is, yeah, page 6. You can complete that whole page. You can do 65. 66 and 67. And then 70 and 71. And that, get done that, we should be okay. You could look at 72 after the fact, but for right now, that's all I need you to do today. Yes, sir.
Do you have our tests?
Okay, I'm gonna tell you this once and once only. How many times have I asked you for your homework this year? 0 times, is that correct? Don't ask me for mine ever.
Okay.
Big pet peeve. Takes a lot longer. If it's not posted on Power School, it's not done. The moment it's on Power School, then you'll get it back. You'll know.
Okay.
I'll post it. As soon as I'm done marking, they'll get posted. Don't have me for them. Okay? All right.
My
We're working on it.
turn to give them all backwards. Go ahead.
We're not continuing that class.
65, 76, 7, and 71.
Absolutely. Okay, you gotta, alright. How did you? Where is it? Oh, no. No. Good. First of all, you never add your bottoms together ever in anything you do. You never add your bottoms. Okay, so we change this to an improper fraction. 4 times 2 plus 1, 9/4. Add 2/3. So now you need a common denominator. What's common between 4 and 3? What are they both going to? Okay, so what do I times 4 by?
3.
And what do I times 3 by? 4. So I'm going to times this by 3, and this by 3, and this by 4, and this by 4, right? So I got 27 over 12 plus 8 over 12. Now you add the tops and the bottom stays the same. Okay?